Okay, good morning, students. So today I'm going to explain about convergence of positive real sequences with the help of ratio and root test. So, so the first one is ratio test. So ratio test tells us that sequence AN is convergent if limit an plus 1 upon an is equal to L, where L should lie between 0 and less than 1. If L greater than 1, an diverges. If L is equal to 1, test fails. Right? Second test is, sorry, yeah, this is ratio test. Second test is root test. What does this test tell us? This test tells us that sequence an is convergent if limit modulus an power 1 by n is equal to L if L 0 less than or equal to L less than L 1, and if L bigger than 1, an divergent. If L is equal to 1, test fails. So in both these cases, if the sequence is convergent, means that L is lying between these limits, then the sequence converges to 0. Okay, in this case. Similarly, in this case, you have sequence converges to 0. So, I have some examples. We see these examples in this video and then we'll wind up. So the first example is un is equal to n factorial by n to the power n. So first let me try to use the ratio test. Okay. So in order to use ratio test, I need to find un plus 1 upon un. So this is n plus 1 factorial, n plus 1 the whole power n plus 1 into n to the power n by n factorial. So which gives me um, n factorial gets cancelled. So 1 upon 1 plus 1 by n the whole power n, which is 1 upon e, which is less than 1. Hence, my un is convergent, and also we made that it converges to 0. So the limit of the first sequence is 0. Second example, un is equal to 4 to the power 3n upon 3 to the power 4n. So now you can use the root test, right? Root test, because it is very easy when it comes to like power n. So un power 1 upon n is equal to 4 to the power 3 divided by 3 to the power 4. So my target is to find this value is less than 1 or greater than 1, right? So 4 to the power turns out to be 64 and 3 to the power 4 um, means 9 is 81, which is obviously less than 1. So un converges to 0. So this sequence also converges and converges to 0. What about the third example? So b bigger than 1. Right. So third example, un plus 1 upon un is equal to b to the power n into b divided by n plus 1 into n factorial by b to the power n. So if you solve this, you will get n plus 1. Right. So as n approaches infinity, this goes to 0, which is less than 1. Therefore, this converges and converges into 0. So these are the three examples and root test and ratio test. This helps to solve many problems in sequence examples. Right. So I'll see you in another video. Thank you.